built really just smaller gas-fired plants that you could bring on and offline as you needed to serve those really high loads during the summer periods. That pendulum is now shifted back to where we need to start building those large baseload power plants that operate 24 hours, 7 days a week. And so energy companies now are looking at what can they build to serve that 24/7 load that's cost effective for their consumers, that's good for the environment, and that maintains that fuel diversity that energy companies like to have. They like to have nuclear, coal, gas, and renewables all in the same portfolio, much like we would our stock portfolio. You'd want it balanced. So nuclear is going to be part of that going forward.
Right. If Company A announced their plan to build, let us say, a 1,500 megawatt, 2,000 megawatt nuclear power station today in early 2008, how long would it be before it was online? And I can't make an exact mathematical prediction, and how much would it cost?
Well, we have actually 6 companies who have already made that declaration of submitting a permit to the Nuclear Regulatory Commission with the idea of building new reactors. The way that's going to play out is they will submit that application to the NRC. The NRC will take roughly 3 years
NRC
to
being the Nuclear
Regulatory Commission. They will take roughly about 3 years to review that permit. If it meets all the safety criteria, they will get a permit to build it.
3 years just to review the permit?
That's correct.
What are they doing?
Well, these
they
are
only got 6 applications and they're taking 3 years?
Well, these are applications that are thousands of pages of details. So we have to, the NRC wants to make sure, and the industry wants to make sure that we're going to build the plants according to the designs, and then take care of the environmental issues along the way. So it does take time to review.
So they're spending 3 years on it, then what happened?
And then it'll take 4 to 5 years to build. So we look at the first wave of 4 to 8 reactors, somewhere in that ballpark, coming online in the year 2016 or 2017. And if those projects are going well, you'll see a second wave of reactors that's already starting to be permitted and built that will come online in the 2025 timeframe. So today you have 17 different companies or groups of companies that are looking at building up to 30 new reactors by the year 2030.
I said in my introductory statement, it was based on information you supplied, by the way, that France depends on nuclear power to the tune, if you will, of 70% of its needs. And there are other companies, Germany, Norway, Sweden, Finland, all that very high proportions of power. I think even Japan, 50%. Correct me if I'm wrong there. What's that all about? Well, here we are, 20%, a highly advanced nation. 20% of our power, no greenhouse gases, no air pollution, some environmentalists coming on board.
2 reasons. You have to look at the denominator, and our denominator of electricity usage is far superior to those other countries. You also have to look at the natural resource base that we have in our country that France and Japan and other countries simply don't have.
As in coal, gas? And
coal, natural gas. We have those resources. When you look back at the 1970s, the early 1970s, when the first Arab oil embargo hit this country, and we're now suffering again from high oil prices, and it's quite an issue with our economy and our energy situation. But what France and Japan and other countries that didn't have those natural resources and were dependent on imported oil, they took their energy philosophy toward nuclear. And so they essentially backed foreign oil out of their energy system for electricity. We did the same thing largely in the U.S. In 1973, we had about 20% of our power that was generated by using oil, and nuclear all but backed that out over the 70s and 80s. So today we have 20% nuclear and about 3% oil. We just happen to have indigenous natural resources that those countries don't have.
Help me with this. Somebody advised me that in Japan, for example, I could be all wrong on this, and I know you'll correct me, and I want you to, there are only 5 or 6 standardized designs. And I was further told that one of the flies in the ointment, if you will, is that in the United States, of the 104 online nuclear reactors, every one is not fundamentally different. They still use the power of the atom to boil water. Right. So that's a constant. But in some ways, they're substantially, if not incredibly substantially different. So if we would get 4 or 5 designs pre-approved, except perhaps just with one factor, the amount of land it took or the amount of power output from the plant, Wouldn't that expedite the process?
And that's exactly the lesson that we've learned really from looking at the French, because the French did this the best when they built their plants in the 70s and 80s. They did standardize around 1 or 2 designs, and they happen to be U.S. designs. And so what we're doing is learning the lesson of that standardization around one design, so that once you put in permits for the first of that standardized design, the second, third, fourth, and every permit after that
speed up.
Will speed up, and that's the philosophy that we're using. You also get very much economies of scale on sharing spare parts, sharing maintenance and operation knowledge, and that's certainly something that our industry values.
The price of the plant goes down.
It does. As you build, you build the first model, that's your baseline plant, and then you get economies of scale as you go forward, both in lessons learned in construction and management, and in being able to construct those plants faster, but still within the specifications of the design.
We do have to take a break, but I do have time to follow up one of my own questions. You gave the time frame, the 3 years with the NRC and so forth to bring the plants online. So we're looking at a 2,000 megawatt plant. How many, we're looking not at millions, but billions, are we not?
Dollars, yes.
How many, how much?
Well, the cost estimate now is somewhere in the range of $5 to $7 billion per reactor. And that's a range of 1,100 megawatts to 1,500 megawatts of power coming out of those reactors.
Okay, folks, it's interesting so far, and I'm sure it'll be much more interesting. Stay with us, please. I should say we will be right back.
The views expressed on Make Peace with Nature are those of the participants and not necessarily those of this station or the program's underwriters.
Some people are pro-nuclear but don't want it in their backyard. These people in the boats and the man fishing there, he didn't seem to mind that just a couple of miles off to his right was a nuclear reactor. It's called NIMBY, N-I-M-B-Y, not in my backyard syndrome. Is that a problem for you?
In Texas, they call it PIMBY, please in my backyard, because we're developing new reactor projects in Texas and many other states, and there's a town in Texas called Victoria, and they are actually soliciting one of our companies to build new reactors in their town because they understand the safety of those plants. They see those plants as just tremendous economic development engines in their communities, and they're very comfortable with the technology and having those plants built in their communities. And we see that really across the country with companies looking at adding new reactors. They're going to do that in many cases at existing power plant sites who already are comfortable with that technology and have seen the improvements that those facilities have made in their community.
All right. We're in about 1 minute. We have to start, or I would like to start a video which you've been kind enough to supply to us, but let me just set it up. Some people who object to nuclear power, if you can answer this in a minute, and I'm sorry to burden you with that time frame, believe that when the nuclear fuel rods are spent, the basis of the device, they're still radioactive and they have to be stored, presumably off-site, ultimately in some safe place. They're worried about trains coming through their neighborhood and trucks and whatnot carrying this stuff around to go from the plant to some place where it's stored. So you don't believe that's a problem?
It hasn't been a problem in 3,000 plus shipments that we've conducted since the 1960s. We've made those transportation shipments safely. They're monitored by both the industry and the Department of Energy. So no, we believe we have a well-demonstrated record of safety in moving used nuclear fuel in this country.
All right, with that, I'd like to present this video, please.
More than 100 nuclear power plants provide the electricity for 1 of every 5 homes and businesses in America. They are a vital part of our nation's future energy and environmental policy. Nuclear power plants are the nation's largest emission-free source of electricity because they don't burn anything to produce electricity. Used nuclear fuel is a byproduct of nuclear energy and is being managed effectively. America's used nuclear fuel management program includes shipping used fuel from nuclear plants to a remote underground disposal facility. Public safety is the priority every step of the way. It is ensured by a combination of protective measures. Super strong shipping containers that provide multiple layers of protection. extensive planning and processes governing shipping routes, and comprehensive regulations governing all facets of this program. The result is that the public and the environment are fully protected. Since